Hello, everyone. My name is JANI RIPATTI. I'm working for Juniper Networks in Finland, covering also the Baltics. Some of you might see me before in the roadshow in the past years. And last year we had the hacking competition. Who won it? Is the winner from the last year's competition here? No? Okay. Maybe, yeah, he's not here. This year I have a little bit different agenda. It's about DDoS and what we are doing on the DDoS side and how we prevent DDoS on our customer environment. By the way, as a warming up question, is there anyone who has experienced any DDoS? Don't lie, don't be shy. 1, 2, 3, 4. Is there anyone who has ever ordered a DDoS attack? I'm not revealing you. No problem. Yeah, I've tried it, and it's scaringly easy. You just Google it, and quite easily you can find vendors for DDoS, and you can pay online, and you get even SLA for your DDoS attack. So it's really easy if you want to get DDoS against your worst competition. So my agenda today is talk a little bit about our DDoS solution, talk a little bit about our hybrid solution together with VeriSign against volumetric DDoS attacks, and then if it fits into 35 minutes, I hope I'll be fast enough, we will have a live demo which I'll be running on my laptop. I will show you how our solution is working and how BGP flow spec can be used as a protocol to tell the upstream routers to slow down the amount of traffic they're sending. So let's get going. Evolution of DDoS attacks. Yeah, some of you who have already experienced it know more about DDoS attacks. Usually what comes into people's mind when we talk about DDoS attacks, it's the volumetric attack, and that somebody from usually distributed sources are sending huge amount of traffic, which is usually jamming basically everything. Nowadays, the volumetric attacks are still there. They are getting even bigger and bigger. This year we had the record-breaking over 400 gigs of traffic in one volumetric DDoS attack. And you can imagine that if you get over 400 gigs of traffic to your network, how it will survive. So even the highest scale service provider networks are struggling with it. More later development in the DDoS evolution is this kind of more targeted DDoS attacks. We call it the low and slow type of approach, where we can jam the application, and it attacks the application vulnerabilities, or actually not necessarily the vulnerabilities, but how the applications are behaving. Especially, it's quite easy to jam a whole HTTP web server with this kind of, for example, slow LORIS or slow HTTP connect type of attack. So it's relatively easy, and if you don't know how to do it, you can go to YouTube and look for instructions, and then you can launch your low and slow type of DDoS attack. Latest development also on the DDoS attack side is that, by the way, who has Android phones? Okay, more people than the ones who have ordered the DDoS attack. But on Android phone, you can actually have a DDoS platform. You can have a low orbit ion cannon on your mobile platform, if you wish. And if you think that we are getting more and more 4G, LTE connectivity and bandwidth on our mobile platforms, if you imagine that we can utilize all that bandwidth from the mobile platforms, and you also know the amount of mobile platforms out there, it's quite tempting environment to be used as a platform for DDoS attack. Different kind of DDoS attacks and what are their characteristics. The volumetric I was already discussing about, so that's the most common one. It's also the most easiest one to detect. Usually we know that if there is normally 1 gig of traffic coming in and now there's 10, maybe there is at least 8 too much usually, and that's quite easily detected. Then we have this kind of attack behavior, which is making the resources busy. It's not necessarily DDoS attack. It can be, for example, lots of people, for example, rushing into online ticket store to get tickets for fancy whatever artist is coming to the country and making only one show. So everybody wants to rush into the online ticket system when it opens up. It makes the resource busy. It's not made to be handling so much traffic in the peak. Also, this kind of flash mobs that are getting more popular, that in social media people are saying that now we have this one organization who is doing bad things, now everybody go into their websites and make it busy, and it might crash even because of that. So we call it flash mobs. Then the low and slow, and this is the part which is evolving the most. And the problem for this is that it's really hard to detect. It makes the resource busy. It's usually something that goes through the normal firewalls. It's HTTP request, and usually what it does, it just leaves the connection open. So we open as many connections as we can, and that will eat up the connection table from the web server, for example. And there might be some backend weaknesses, for example, databases, which we can utilize also, that we do database queries through the web front end, and that makes the resource busy. And that's also one form of low and slow attack. More recent types of attack, especially I told you about the highest volumetric attack ever happening earlier this year. It was using the NTP amplification type of attack. It's quite nice on those legacy UDP protocols. You can do a nicely spoofed attack where you can use the service as a reflector. And for example, on NTP, what you do, you actually spoof your source address, and you send it to the NTP server, and NTP server, what it does, it tries to respond to the spoof IP. So especially on NTP, if we use the monlist command, which will provide a list of previous NTP clients the NTP server has had, the problem is that with one small query, we'll get huge amount of traffic. And that amount of traffic, or the response to the query, is going to be sent to the spoofed IP, which is actually the victim of the DDoS attack. So that's the way how we, or who wants to do the DDoS attack can utilize the reflection to make the volume even bigger. So the idea is to amplify the original stream of traffic. NTP, DNS you can do, in theory you could also use SNMP. SNMP uses password, which in many cases can be public or private, so that's quite easily figurable. But that's also something that can be utilized as a DDoS attack. Low and slow, this is the one which is getting more and more attention, and this is actually where our product is really good to see this kind of attacks, which are not actually detected usually because of the high volume, but it's detected because it makes the application slow, and it eats up the resources from the web application. how we are approaching the DDoS, we acquired a company called WebScreen in February 2014, so less than a year ago. And WebScreen was a company in UK which has been building the DDoS platforms from 2001. So it's one of the very first vendors ever who have built DDoS platforms or anti-DDoS platforms. And that's the only thing that they've ever done. And they're only building DDoS platforms. Of course, this kind of products, we have some names for the ones that we are protecting, but of course the customers don't like to be published so much. But if you're interested, we can provide some references. But usually they don't want to tell about the protection system. If you don't remember anything else from this presentation, remember that our DDoS platform is high-tech and low-touch. So good thing in our solution is that it learns itself. So you put it in the network, you leave it there, it will by itself, it will see what kind of traffic you have, what kind of response times you have from your services, how much of traffic is coming from different countries, from different source IPs. So it will learn by itself, and there is nothing to update. It doesn't have any signatures. Only thing that has to be updated is the geo-IP database. So if you want to map your source IPs into flags and source AS numbers and source countries, then you need to update the geo-IP database. But there is no signatures for the DDoS detection. That's a good thing, because like in antivirus field, we need to have, if we talk about traditional antivirus approach, we need to have, first we need to have the virus, and then we can figure out how to cure it. Also same thing in our platform, because it doesn't need any signatures. It can protect against zero-day attacks in the network. Also, if you want to have a more scalable solution, like against really high volumetric attacks, you can use the Verisign solution, which is the cloud-based hybrid solution, or then you can use BGP remotely triggered black hole routing or BGP flow spec. Two BGP-based protocols that are built into our solution. And on the demo, I'll be showing how the BGP flow spec is working. There's two key concepts in our platform. We have something called charm value. It's a numerical value how charmful the source IP is. We give the value for the first time we see the source IP from mid-level from the bar, and if it's a machine-like communication, it's usually quite deterministic, and you can say that it's like a machine which is getting something from the pages or from the web service or from the DNS server, for example. If it's a human or normal approach, usually when you're browsing website, you are clicking here and there and having a coffee in the middle or discussion. So it's not, it's more human-like. It's not predictable. When you behave like this, you get a higher charm value, and if you behave like a machine, if you behave badly, you get a lower charm value. And if our resources are getting busy, we raise the bar for a minimum source IP charm value that is getting through to the service. And this is why the probability for the false positive is really low. So we say that after 12 hours of operation, we claim to have 5 nines of accuracy in like the detection and precision. But yeah, customers we have met using this, they say that it's really accurate, that they don't see any false positives. One Other key concept is the resource health. So we see, usually we deploy the DDoS platform in line in the edge of the network, and we see the traffic coming in and traffic coming back. And that way we can see that how the resources are behaving and how well they're responding. So we see that if there is a HTTP request going to the server, we see that the response in normal situation takes like 1 millisecond. And now if it gets slower, it takes 2, 3, and it gets even slower. Then we start to raise the bar for the charm value. So that way we prevent the destination to be over-exhausted. There is also first line of defense, let's call it that way. So there is 2 phases. This is the second phase, but in the first phase there is another filter. We call it this kind of filter which takes away non-RFC type of traffic, out of sequence type of traffic, for example, port scans, SYN floats, this kind of things that are always there when you are putting something in the public network. But it will filter them immediately away from the traffic, even before going to this charm value based filtration. So it by default cleans up your traffic. Like I mentioned, really low probability for the false positive, and that's really important if you're running, for example, a web shop. So you always need to get the customers in who are paying for the service and not trying to break your web store, and that's a really good thing. And one other thing, which is quite usually the sweet spot for our product, is the online gambling business. So there's lots of traffic coming in. Someone is behaving badly, but we still want to enable the service for those ones who really want to gamble. And another thing, the thing that I was mentioning in the beginning, is the online ticketing system. Usually it's not the DDoS, but there's so much people coming in to buy the tickets that it slows down the system and nobody gets a ticket. So that's one place where we are using our devices to enable the web shop, even for smaller amount of people, but to make it possible to buy the tickets. So usually the ones who are the quickest one to press the refresh button are not going to get the tickets, but the ones who are behaving like normally, they've been searching the same page yesterday evening maybe, or evening before, and get the higher charm value, and then next morning when the tickets the sales are opening, they get immediately to the system. So that's a way how to get around it if it's in a ticketing system. But yeah, if you're behaving good, it lets you in. There is also a good thing that there is nothing required on the server side. So you don't need to install anything on the servers. It's like watching it from the edge of the network. So no clients, no fingerprints needed on the DDoS platform. There's 2 form factors. You can have it as a software, like I have on my laptop. Usually it's more for cloud service providers. And if you are like in the normal use case that you are like protecting your network from the edge of the network, then you use the hardware. Because on the hardware side, there is also a good thing that the network interface cards are fail-open type of cards. So if you need to upgrade it, or if you lose power or whatever happens, it will bypass the whole system so that all the traffic goes through like it was like a straight network cable. We have 1G, 10G versions available. Bigger ones are also on the roadmap, but we can already scale up to 120 gigs by bundling these 10G boxes together. So that's quite good enough. On the virtual side, the max throughput per virtual instance is 1G. if you go to the licensing, so this is only the hardware, and then the licensing is throughput based. So it's in steps of 1G. So you get 1, 2, 3, 4, 5, whatever, how much DDoS bandwidth you need to be protected. So that's the way how the licensing and hardware is going in our solution. Then on the cloud side, if you want to have this kind of off-site scrubbing for higher volumetric DDoS attacks, then our offering bundles together with VeriSign. So we have similar systems in VeriSign Cloud, in the VeriSign data centers. And what happens if you experience this kind of high volumetric attack, we will signal the rerouting of the traffic to go through the VeriSign data center, and it will clean up the traffic and reroute it back to our site. So in EMEA, for example, it's for example in Frankfurt, you can do the scrubbing, so not too far away, and that's the way it goes. These are the locations for the scrubbing centers. So Frankfurt, Amsterdam in EMEA, and other ones around the globe. So those are the places where the traffic cleaning is happening. How it works? You always need to have the device in your premises. So that's the place where we initiate the rerouting request to the VeriSign Cloud. So that's mandatory. And how it really works, I have a flow chart here. So this is the case where everyone is behaving good. So traffic is going in to the customer side, and this is the applications they're reaching. Then we have the stealth attacks, which are not consuming so much bandwidth, but these are getting protected already by the on-premise device. Then if you get the volumetric attack with really high volume, we will signal it to VeriSign, which initiates the rerouting, and then all the traffic will go through the VeriSign, and only the clean traffic will come back to the site. So that's the way how it works. Then I have still 5 minutes, 10 minutes. Now we go to the demo. I hope it works. So what I was planning to show you is how we can use our platform together with the routing systems, whatever routing system or router you have, which is supporting BGP flow spec, you can use here. I have virtual SRX, the virtual firewall, in my laptop, which is this one. Then I have the hacking platform. Then I have the DDoS protection application. Then I have a web server, and then I have a monitoring or GUI to the system. So everything is running on my tiny laptop. And usually when you're doing this demo, it's the place when you get all your 4 cores to peak and up to 100%. So this is how it looks like. This is our DDoS platform front page. Here you see what kind of attacks you have had, how much volume has been going to your services. Normally, if it's in a live network, you will also see. No, it doesn't show it. It's too big. You will see everything which is what's happening in your network here. You see inbound, outbound traffic, and here you see red lights popping up every time when you have different types of attacks coming up. And now what I'm planning to do, I will do first something easy one. So I'm sending traffic from spoofed source IPs just to show that there should be something happening. Yeah, there is something happening. We see traffic going through. Here we see good traffic. Of course, these are all spoofed, but somehow it takes the United States and Germany and China. It changes all the time, but it will, based on the source IP and where the source IP is mapped, it puts into the country category. You see here the portals we are protecting, and we see the level of minimum charm value. Of course, now it says 0. There is like nothing really slowing it down, because everything which gets filtered, it's filtered in the first phase of the process. So there is no charm process needed yet. And we see that there is TCP attack coming up. If we want to dig in, I can click the TCP attack. I can see that what's happening, from which sources. And actually, if I, sorry, not that one. If I go to country usage, I can see all the source countries. And if I want, for example, block China, I don't know if nobody wants to block China, but I could block China by blacklisting the whole country, or all IPs which are mapped into China. Not going to do that now. But next thing, what is going to happen, I will send much more traffic. I will send so much traffic that it will be treated as one source of an attack, not a spoofed one, but I will send the traffic from the original source IP, and the platform should detect it as an attack, and it should launch and reroute, BGP flow spec reroute, and it should advertise the BGP route to the firewall, which is handling the BGP routing in my case. So now there is a lot more traffic coming in. Let's see how much. Usually, in this point, my laptop starts to melt. I can push, it's approximately 30 megs of traffic. It's quite okay in this setup. But now I should see an incident here, and temporarily blacklisted. And it has already blacklisted. This is the 10.20.2020 is the source IP from my hacking platform. And it has blocked all traffic from that source. And if I go to the reroute information, BGP flow spec, it shows me that it has created an active BGP flow spec route for this source going to this destination. The good thing in the BGP flow spec is that it can also look into the source of the traffic. If we take BGP remotely triggered blackhole routing, it can only in the mostly spread version, it can only use the destination as a black hole, or the destination what should be black holed. The problem in that one is, we also support that, but the problem is that when you black hole destination, the DDoS attack will be really successful because nobody gets into the service. It will black hole everything to that destination. But with the BGP flow spec, we can say that the destination is this one, and the source is this one. So that way we don't block everything, we just block the bad things. We block the bad sources. Also, if it's coming from NAT address, we can also use ports, source port, destination port. So that's built into the BGP flow spec. If we look into the routing, this is the firewall which is doing the routing in this case. I show you the BGP flow table. I can see the flow table here, and I can see that there is this kind of information coming from the DDoS platform. It shows me the AS numbers, it shows me the traffic rate. So you can, for example, say that if the source is this and destination this, we rate limit to 10 megs or 5 megs or whatever by default. So that's really nice thing in the BGP flow spec. And also good thing is that if I now close down the attack, everything should be torn apart. Everything should go away. So now I will stop the attack. First thing, we should see the flow spec route here disappearing. It takes a while, I hope. These are usually the longest seconds. Yeah, now it went away, and now it shouldn't be in the routing table at all. So, magic. That's an example how we can utilize the BGP flow spec together with our DDoS platform, and how you can use it to protect your network against DDoS attacks. Any questions? No? Not a single question? Please, at least one. Everybody else has got the questions, but not me. Okay, I'll be here for a while, and my colleagues will be here all the night. So if you have any questions, please reach out, ask me, my colleagues about the solution, and Santa Monica guys, of course, they have also knowledge about the system. So reach out. Thanks.